Welcome to EDU World Space.
So firstly, for this problem, let's write down the velocity of the particles relative to the Newtonian frame, Vi, as the velocity of frame A, Va, plus the velocity of the particles relative to that frame, Vi prime. So this will come in handy later on. Now, let's write down the angular momentum about point A. And the angular momentum is defined as the sum as I goes from 1 to n, with n particles in the system, of Ri prime crossed with the momenta of each particle, Mi, Vi. So essentially it's R cross P summed over the entire system of particles. And we can write this as the sum as I goes from 1 to n of Ri prime crossed with Mi, and we'll replace Vi with the expression above, which we said was Va plus Vi prime. So now we can split up this cross product. So essentially we have two sums here. So it's the sum from 1 to n of Ri prime cross with Mi Va plus the sum from 1 to n of Ri prime cross with Mi Vi prime. So now we expanded the expression and included two sums. So the first one is the sum from I going from 1 to n of Mi Ri prime cross with Va. So we've just written this slightly differently. Mi Ri prime cross with Va plus, if we look at the second term, we can see that this is a position vector crossed with a momentum vector. So this is essentially an angular momentum H prime about A. So that is H prime A. And so we can write R prime as the following. So this is the sum from 1 to n of Mi, and we can write Ri prime as Ri minus vector Ra. So we just expanded Ri prime to Ri minus Ra, and that vector crossed with the velocity Va plus H prime A. So we can see from here that HA, which we have on the left-hand side, can equal to H prime A if and only if M into R minus Ra crossed with Va is equal to 0. So we can have the left-hand side equal to the right-hand side if this is satisfied. So there's three ways in which that condition can be satisfied. So this condition is satisfied firstly if Va is equal to 0. So point A has 0 velocity. Secondly, B, that the mass center R is equal to vector Ra. So this tells us that point A coincides with the mass center of the system. and see if VA is parallel to R minus RA. And that condition tells us that velocity VA must be directed along line AG. So this condition is satisfied, or this equation is satisfied, HA is equal to H prime A, if either one of these conditions are met.